I'm Greg from Greg's Tutoring at NYC at gmail.com. What's happening, YouTube? Huh? So we're going to continue to cover ISEE problems from the ISEE sample. These are very SHSAT-like at this point. Most of the ones for today, I believe, are going to be nice and meaty problems. So please email if you have questions about the ELA part, the math part, how the SHSAT works, how the ISEE works, how just standardized testing works. I do a lot of standardized testing tests. A lot of them there's a common part to a lot of them, there's a lot of different parts to a lot of them. And it can get very confusing even if you only do one. How do you register for the SHSAT? What time do you register for the SHSAT? How does the process work? Families get all bent out of shape. Kids get upset. Parents get upset. Nobody needs to be upset. So with me all fired up, let's go. All right, so let's jump into the next problem. I think we did this one yesterday. Problem number 10. Let me see if my screen is right because I think I shifted things around. Nope, that looks okay. Let me just keep this over here. Let's see, where are we? All right, so we're going to go somewhere between half an hour and an hour today. I have to see how the problems are going and so on, because we don't want to blow your poor little minds away. So it says, what is the value of the expression? In fact, let me bring this up because I want to make sure I have the numbers going right. One of the problems I noticed, by the way, in passing, is if something has something like 3 plus 4, in a lot of the fonts, 3 divided by 4 can almost look like it's the same operation. So for people with glasses or who should need glasses, like my eyes are weak at this point, and sometimes I have to actually double check that that's there. I also have slight dyslexia, so I can see different digits sometimes. I can even see, especially if it's something like 3 plus 4, I can sometimes see that as an 8. And even the 4 can be a different digit to me sometimes. So if you have issues like this, please double check what you're doing, especially if you're copying some of this stuff. All right? So it says 3 times 3 to the squared plus 3 to the cubed over 9 times 3 plus 9. All right? So this is a cutesy one. Just let me make sure this is coming out right. Yes, it is. So I'm going to double check that I actually copied these exponents right. 3 times 3 squared plus 3 cubed over 9 times. So there's a few ways to solve this. One is we could make these into their whatever 3 times, 3 times 3 is 9. 3 to the third is 9 times 3 is 27. We could collapse this to 12. Okay, and at this point we can do some canceling out and so on. You could also just do the distributive property. So we can get 3 times, in other words, this is the same as A times B plus C, right? So we can do 3 times 3 squared plus 3 times 3 cubed, and get 3 to the cube plus 3 to the fourth. Over here, we can do the same thing here. This really is the same as A times B plus C as well. So we can do 9 times 3 plus 9 times 9. That gets too busy. It's just easy to collapse this in 12. The denominator becomes 108. Right? And let me make sure this isn't falling off the screen. Yeah, it is falling off the screen. Give me 1 second. All right, sorry about that, people. So we get a denominator there, and we can also get it up here. So we can get, what do we get here? 3 to the third is 27, and 3 to the fourth, we get 9 times 9, we get plus 81. So it turns out we get 108 over 108, and that's equal to 1, which should be B. Right, so be careful with your math here. Note that it is the distributive property. Even if you added this up here first and then multiply by there, you don't have to do the distributive property. You could also get the sum inside of here. I said this is 9 plus 27, which gives 35. 30, gives 36. And 36 times 3 gives 8. 1 gives 1 away as well. So there's a couple ways to solve this. Here's the gotchas to this, that when you have 3 times 3 squared plus 3 to the cubed, there's so much going on here that most kids are probably going to multiply this and then add that. They're going to make this 3 times 3 squared plus 3 to the cubed, forgetting that it's a times b plus, or it's this has to rainbow out to both of these. Okay, they're going to forget about that. That's probably where some of those other answers came from. In fact, some kids might even do it down here. This is busy enough to confuse somebody sometimes. So they might do 9 times 3 is 27, plus 9 is 36 as the denominator, which is completely wrong. All right? Okay, there's another way to observe this problem. Let me make sure I write it down again. 3 times 3 squared plus 3 cubed over 9 times 3 plus 9. Okay, the other way to observe this problem is that if we just look at powers of 3, this is 3 to the 1 times 3 squared plus 3 to the third over, now 9 is 3 squared, 3 is 3 to the 1, plus, and this 9 is also 3 squared. And we end up getting, I mean, you could just see this, but it's 3 to the 1 times 3 to the 2. I ran out of space here, so we get 3 to the 1 times 3 to the 2 plus 3 to the 1, 3 to the 3. And the denominator is 3 to the 2, 3 to the 1 plus 3 to the 2, 3 to the 2. Now, this is 1 and 2, and this is 2 and 1. And this is 1 and 3, and this is 2 and 2. That's important because we're going to get 3 to the third plus 3 to the fourth over the same thing, 3 to the third plus 3 to the fourth. So that's the identity as well. So we could actually solve this without getting the numbers. Both of these are kind of tedious solutions, but it's a way to confirm that you're barking up the right tree. And even though in this example, these are both tedious, you have to observe and be aware of situations like this in these kind of problems. A lot of people like to say, oh, that's tricky. Well, yes and no. I like to say they're testing your mathematical mastery. I don't believe it's tricky. They're asking you a mathematical question, and these are basics of math that you're supposed to know at this point. So, you know, and that said, it can be confusing. So you have multiple ways to do this here. All right, so that's that question. Number 11. Okay, I'm going to do my usual. This is not fitting on the screen, which is fine for now. I'm just going to look at the graph. I'm going to look at the illustration. I'm not going to read the words. So, and I'm going to read the title of the graph. I'm going to read what the x-axis and the y-axis is. And I'm also going to see if there's any other annotations or captions written in the graph. So it says Jane's Walk. Not really too detailed here. The bottom says time in hours, and the left-hand side says distance from a home in miles. All right, so it seems like she's walking away from her home somewhere. And I'm just gonna start interpreting the data at this point. Again, it may not be the question. I'm trying to understand what the illustration is even there for. Okay? I'm not going to spend thousands of hours doing this. Right now, I'm kind of expanding this out in kind of elongated form. But on a real test, you're going to do this in a couple of seconds. Oh, look at the graph. What does this mean? What does this mean? And you might test a number or two. So, for instance, you notice it starts at 0. Okay? And by the way, you know that because if it didn't, a graph would have kind of a squiggly line here or a squiggly line there, meaning they left some stuff out. So that's not there. So it's starting right at 0. It ends at 2 hours. Okay, and it looks like the furthest she ever gets from the house is a mile, because at 1.25, that's the highest that meets. And then it looks like she walks straight home. So I don't know what the heck the question is here. It looks like she walks, then she goes straight, then she walks more, and then she starts returning home. Because again, this is the distance from her house. So she's going further and further away, and then eventually comes back. All right, and I can get the range. The range is 2, 0, minus 2 minus 0. Also, the range for the distance is 1 minus the thing. So again, I'm beating this to death. So let's go back to the words. The graph shows the distance Jane was from her home as a function of time during the walk. So at 1 minute, she's about, she's getting close to 0.75. At 1.25, she's at 1. And at 2, she's back home. All right? So this is because she's 0 distance from a house. All right? And we could do it backwards. We could say how far away is she from a house? How long has she gone when she's half a mile away from a house? Well, one has her between 0.75 and 1 on the way there, wherever she went. And the other has her about between 1.5 and 1.75. All right? So that's that. So I'm going to scroll the top off because it's not fitting. In fact, I might just bring it to this. Let me see what's going on the screen. Yeah, that's about the best we're going to have to do. So let me make sure the stream is still going. Yes, the stream still seems all right. All right, so what does it say? It says, at one point in the walk, Jane stopped for several minutes and waited for her friend. How far was Jane from her home when she stopped and waited for her friend? So let's follow the line. So from 0 to 0.5, it seems she's consistently walking somewhere. And she's getting further and further from her home at a constant rate. Because we go over 2 and up 1. And then from 0.5 to almost 0.7, right? She seems to just be the same distance from a house. So either she's walking in a circle or she stopped. And then, just before 0.7, she moves on and then moves on. So the only point where she seems to stop is from the 0.5 to the 0.75. And we can double check another fact because it tells us she stopped for several minutes. So she stopped between half an hour at the 30-minute mark to maybe the 0.7 mark. So yeah, that's a few minutes. I mean, greater than 2 is already is more than 1 minute. Is minutes. It's not minute. Okay. So it seems like it's 0.25, which would be A. What question number is that? That's number 11. Is A? Yep. Okay, 12. Okay, 12. Let me make sure this is showing on the screen. No, it's not. So let me bring that over there. And this little part still not showing at the bottom. Okay, D says range for anybody who can't see that. I'm not sure whether to cut off the top or the bottom here. Because if I play with making it the teeniest bit smaller, it's going to get thrown off. So we have another table. So let's look at it. I'm not going to read the words. I'm going to look at the illustration. It tells me this is about statistical measures. It tells me the measure and the value for the measure. So these are terms, averaging, centraling terms, they're called. Terms of centrality that come up, since you really should be having since grade 5, even before. These only come up once a year, really, when you do the state test. But they'll come up more when you do the integrated algebra and some algebra as well. So depending on what you've done or not, because it relates to standard deviation and some other concepts, which you do not need to know for the SHSAT, nor do you need to know for the ISEE or the SSAT. So there's a whole bunch of questions, certain math topics that are included in some of these tests, and some that are for later years. especially when you get into Algebra 2 and things like that. Okay, anyway, so we have this table that lays out what some of these things are. I can see the mode means 80, the mean, which is the average, means 75. And you need to know what each of these is. The mean means when we take the numbers and divide them by the number of numbers, we get 75. It's the average. The median means we take the counts, how many there are from both extremes, and keep working until we get whatever that center number happens to be. That's different than the average. The mode means how often does a certain number come up the most time. So 80 comes up the most time. And the range is the maximum number minus the minimum number. So again, if you guys don't know these or any concepts, go look them up. Write them down on a piece of paper. Put them in a SHSAT notebook or something like that, or an ISEE notebook, or whatever test you happen to be taking. Because again, these examples go across the board for a lot of different tests. Some of these don't apply to certain tests, like all these don't apply to this or that, but we're rehearsing, we're preparing, we're getting used to this kind of thing. And by the way, for SHSAT takers, I will definitely get into SHSAT specific questions that are intended for the SHSAT at some point. I'm just trying to build you guys up to a good point, all right? Plus you have other facilities. Some of you look at other things online, some of you have other tutors, some of you go to testing centers. And by the way, I'm a tutor, I do private tutoring. I can also tutor in groups. So if some of you guys need my services, please email me. I'm always available. All right, I live in New York City and I can pretty much get into anywhere through a wonderful transportation system. Okay, anyway. So Mrs. Garrett graded the test of 20 students. So there's 20 students. She then calculated the mean, the median, the mode, and the range for the test scores. Okay, so that's what we see below. The table gives the value of each of these stats below. So what we really need, the most, I'm going to scroll this up so we can see it better. So this 20 students is really what the clincher is here. Okay. So Mrs. Garrett, so there's a lot of words here in this problem. They're not necessarily hard yet. Mrs. Garrett decided to add 6 points to each of her students' test scores. And then she recalculated the values of each of the stats measures. So the numbers we're seeing are going to change when she adds 6 to everybody's score. Which of these measures changed the least? Okay, so I can see one that leaps out at me right now. I see we have a few viewers again. Anybody have any ideas on this one? So this is the kind of problem, we don't have the 20 numbers. We don't have the 20 numbers. And this is the kind of problem where if you should maybe make up numbers to try to experiment with them. But do you really want to write out 20 numbers, add 6 to each one of them, and then get the average? That's too much work. So how about we just start out by using 2 of them. Let's say the numbers, instead of 20, let's say there's 2 numbers, right? So if I have 2 and 4, I get the average of that. I divide by 2, so I'm going to get 6. That's equal to 3. So if I add 6 to each number, right? So I'm going to get 8 plus 10 over 2. I'm going to get 18 over 2, and that's equal to 9. So the average went up by 9. Okay, the median between these 2 numbers, there's only 2 numbers, so you go from this side and this side with you put the list in order first, right? So the median of 1, 9, 5, 2, you put it in order to get 1, 2, 5, 9. You cross off this and this, you're left with these 2, and then you get the average of those. So you get 7. So the median here is 3.5. So the median here is 3. So when we added 6, the median here is 9. So that also went up by 6. Okay? So these went up by the same number. This is with the count of 2, not with 20. Okay, the mode, our mode stayed the same. Well, actually our mode changed because we would have had 8 and 10 as the 2 numbers. So in their case, they had 80. So their mode is now going to be 86. It has to be. Because it's the most frequent number, and their set was 80, and they added 6 to each other. The mode stays. So their mode also jumped by 6. Because their mode also went from 80 to 86. And what about their range? So the range here was the max minus the min is 2. And the max here, the range here is also 2. Oh, wait a second. The range didn't change at all. So when their list of 20, it's going to be the same thing. Now their range was 64. So they may have some numbers like, well, they said the mode was 80. So we know there's 80 stuck in here. So let's use maybe 40. And somebody got 104 because they got extra credit. So that's the range there. So if everybody's score went up by 6, it's now between 46 and 110. But when we subtract those, we still get 64. Let me make sure this is showing. Yeah, okay. So the range doesn't change at all. So I kind of went through this elongated-ish, but if you know what these 4 things are, you would know that the range is 0. And it has to be the only answer. Because if it's not, it means the mean was 0, or the median was 0, or the mode was 0, and then the question's ambiguous. There's more than one thing. It didn't say we cannot determine. You know, if it said mean, median, range, and cannot determine, then maybe you have to do all this work. But this is really just testing you. Do we even know what these concepts mean? Do you know what these concepts mean? And you don't need to go using 20 numbers to do this. Because even if I put 20 numbers, I got 6 for some of these here before. Even if that's not actually what happens with the 6, it's always going to be greater than 0 in the range case. So whatever the number happens to be, it's a no-brainer. Okay? All right, so let's bring this up. So it's a good problem though, because it's taking a concept that doesn't come up too often, and it's just beating it to death. And that's what happens with some of these problems, and a lot of tests, all the way up to the SAT and the ACT. Sometimes these are questions that you're again, this is something from grade 5, as I said, and it's thrown on your state test every year. But teachers don't really teach it again. In fact, it was probably a topic that was left to the end of the year. You know, the last 2, 3, 4 weeks of the year where the teacher's still trying to catch up or throwing some data out, or that everybody's being lackadaisical and yada, yada, yada. This is one of those topics that kind of never got covered completely. But it's still on these tests. And you're throwing away points on the state test, and you're throwing away points on something like the ISEE or the SHSAT on topics like this. So when we talk about doing test-taking strategies and working to your strengths and weaknesses and tutoring to the full child, this is part of it. Why throw away a point? So you need to know what these terms are, and they're easy to do. This is a half-an-hour study session. Just looking these up on Google, or going to Khan Academy and running through a few examples, or whatever the case may be. You know, I'm glad to tutor a kid on this, because there is pathological scenarios that happen with some of these things that's sometimes worth considering. But if you don't know what they are at all, you're just completely throwing the points away. All right? So if you're like, oh, wait, I kind of remember that mean means the average, but I kind of don't really remember what mode means, and I'm going to kind of guess this. And at that point, you're just throwing away a point that's been given to you. This is not one of the harder questions. And yet it can be if you're not used to the terminology or doing these kind of statistics, right? This really delves into it's labeling numbers, but it's also doing, what are we going to do with the data? I did a lightning round a day or two ago about angles, talking about interior adjacent angles. That's the kind of thing where you don't really care about because they don't actually ask you that specifically. I mean, if they did, you'd have to memorize that. But what's more important in that case is understanding the concept that 2 angles on a line added to 180. That's more important usually than what it's called, okay? That you just know how to do the thing. In this case here, you have to know what it's called too, because that's what they're going to tell you. They're going to say the mode is 20. Well, duh. You need to know what the heck's going on with that thing. All right. All right. All right. Let's see. So we're getting closer to half an hour here. So I guess I'll chug on for a bit more. Um, so Jim and Maud are playing a game using number cubes. All right. So taking a word problem. How do we progress through word problems? We take it a sentence at a time. We start from the top. If the first sentence has phrases in it, we take it a phrase at a time. So we take the first phrase, we try to understand it. We figure it out, we ask ourselves questions about it. We take the next phrase, which may be a sentence, we try to understand that, and then we try to understand the two things together, the previous stuff and the current stuff. And we just keep building our knowledge based on that. If we're given a fact, we probably want to write it down. Okay? So we want to put down what our givens are. Because givens are also important. And we're just making a mental note, oh yeah, this was that. Or he or she said this or that. Okay? So Jim and Maud are playing a game using number cubes. Okay, cool. Probably they're six-sided. So each player rolls 2 number cubes, each numbered 1 through 6. And the sum of the numbers is recorded. All right, so basically we have two six-sided dice. We assume they're fair, which means that they're not weighted so that like they always roll a 3 or something like that. So it seems like they both roll 2 simultaneously. So their numbers are recorded. So Jim gets a point if the sum of his is 6. So in other words, if he gets 1 and 5, 2 and 3, and that's it. That's his choices. Right? So basically he can get a sum out of 12 because there's 2 dice. Okay? Maud receives a point if her sum is either 6 or 4. So in Maud's case, she has the same possibility as Jim plus another one. Right? I don't know what the question is yet. So I'm just running this through my head. So she can also get the 6, but she can also get like a 1 and a 3 and a 2 and a 2. So she has more chances to get a point than Jim has. So who has the greater probability of receiving a point? Well, I just answered that. It's Maud. Okay? Yeah, 13 is B. All right, so this is really a logic problem. You can run through the stats. It just gets ugly, and you're going to see that because the math is uglier. Anyway, when you do Maud, you're going to see that whatever Jim's probability was, because he's going to get 2 out of 6 twice, so he's going to get 4 out of 12, I guess. She's going to get that plus because it's or. If it said Maud receives a point if her sum is 6 and 4, that makes her possibility harder. Okay? But she can't get a point unless she gets a 6 and gets a 4. But we're talking about 2 dice, not 1 dice. So anyway, just to give some context to it. All right, so let's go on to the next problem. That's 13. 14's a doozy. Let's see, how can we do this? Because first of all, it doesn't fit on the screen. All right, let me get it to fit on the screen for starters. And let me get rid of this thing. Nope, that didn't work. Can we do that? Yeah, sorta. Okay, so we're going to look at the illustration first. We are not going to look at the words. So, it's data. Ta-da! So the values of the data go from 0 to 12. or at least that's what's showing here. In fact, it's showing that the value of the data is going from 5 to 11. Frequency, from 1 to 10. What does frequency mean? It means how many of a certain data there are. So in the case of 5, there is 4 of them. So whatever 5s are, like kids with 5 pieces of candy, there's 4 kids with 5 pieces of candy. There's 4 people online with a $5 bill. Okay, there's 10 people who have $7. Whatever the case may happen to be. So this is more generic here, where we're really just looking at tallies. We're not really caring specifically what the thing is, and it doesn't really tell us anything else. I know when I cough, this microphone just blows my ears out, so I apologize to anybody on the replay and even live viewers. So let's go back to the words. A scientist collects data. Woohoo! Yippee-yi-yay. He determines both the mean of the data and the median of the data are equal to 7. Okay. Let's see. Let me try to get... I think I'm going to have to end up drawing this. So let me try to get a blank page. So, mean equals 7. The median equals 7. So again, you need to know what these terms are, or we got meaningless. These are our givens. If you don't know what they are, it's not going to matter. So again, you need to brush up on this stuff. This could easily be a SHSAT question. To be honest with you, I haven't seen a SHSAT question doing this kind of thing with mean and median, but it's a good question nonetheless. So he determines both the median and the mean of our 7, and the data are symmetric about this value. Interesting. So what does that mean? What does that mean? The data are symmetric about this value. Okay, so we're going to question that. What on earth is being talked about here? So let's say you don't know. So let's read on. He starts to create the bar graph shown, but does not finish the graph. Great scientist there. He collects random data and he doesn't finish his work. Okay, so then there's a slight part cut off on your guys' screen. So it says, if the range of the data is 8 and the maximum value of the data is 11, how many data points fall above the value 7? Ugh. All right, so this is an ugly problem. So I'm gonna try to draw it as best I can. Let me see if this is coming on the screen probably first. All right, so it's chopping it off. Where's my pen? My pen's right there. All right, so this is 10. So this is going to be about 5. And so let's just chop this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 7. Well, this is going to be 11. So we're going to do about the same thing. This is about 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, in your case, you can have the actual test paper, so you are not going to need to have to be drawing this stuff. So it says 7 goes to 10. Okay. 6 goes to 7. So it's about there. 5 goes to 4. 10 goes to 2. And 11 goes to 1. All right, so this is my reinterpretation. Let me just see that. 11, 1, 10, 2, 7, 10, 6 is 7, 5 is 4. Okay, there we go. All right, so also, even though you can do this on your test paper, try to keep it neat, because this is the kind of example you can get wrong, and if you keep erasing it, you want to erase a hole in your test sheet or rip it in half or some nonsense like that. All right, so let me go back to the question. A scientist collects data. He determines both the mean and the median of the data are equal to 7. So this is the median. This line right here. It's the central number. So before, when I had the example like 1, 3, 5, 7, 9, I'm going to cross off like this, and my median is 5. So that's what happened here. Whatever went on with these counts, and again, this is the frequency, remember. Okay, these are the values. So the frequency is the counts. So there's 2 things you have to note on something like this. If there's 1 here, there's a corresponding 1 over here somewhere. And if this is 4 and 7, there's a corresponding 4 and 7 somewhere over here. Right? And by 7, it doesn't mean there's value here. It means the counts. But this is imbalanced. There's 11 here, and there's only 3 here. So let's go back to the question. The median 7, and the data are symmetrical about this value. Oh, that's what they're talking about. So the data is symmetrical. It's, in other words, that's the part that's not filled in. He starts to create a bar graph, but does not finish. So he didn't do the symmetrical parts. So if the range of the data is 8, and the maximum value is 11, so this is max. If the range is 8, that means there's something here at 3. But if the data is symmetrical, then this is going to be 1. And the one next to it's going to be 2. And that means also on this side, that's going to be 4. And this here is going to be 7. Let me just make sure this is coming on the screen right, because if it's not, this is going to be really cryptic kind of stuff. Okay? Sorry for my poor whatever. So let's run through it again. A scientist collects data. Now I think we have it. It determines the mean and the data and the median. We said the median was this darkened line here. The data are symmetrical. We believe we match now. There's 1, 2, and 4. 1, 2. Oh, wait, I did that backwards. This one's 7, and this one's 4. So be careful. Okay? So it goes up the same way, and it goes backwards the same way. Because it's saying it's symmetrical. The line of symmetry is on here. If we take this paper and fold it, we should be getting a mirror image there on both sides of it, with the mirror image reflection happening at this point. Okay, he starts grid graph, whatever. If the range of the data is 8, so 11 minus 3 equals 8, right? The range is the min minus the max. And the max is 11. How many data points fall above 7? So it's going to be 7 plus 4 plus 3. No, sorry, plus 2 plus 1. So we got 11, 12, 13, 14. We got 14. And the answer better be D. Yeah, it is. All right, so this was an ugly problem. that required lots of interpretations of a lot of stuff. It's a good one where you can get a lot wrong. So you have to keep your attention to detail right. And it's, again, you have to be like, what is the mean and the mode? What do they mean that the data are symmetrical about this value, right? And it turns out the median was really the clincher to this. We don't care as much that the mean is the same. And by the way, by virtue of these being symmetrical, we don't have to compute the mean because it's going to balance out. In other words, if I have 80 and I have 75 here, the thing on this side has to be 85 because this is 5-way and this is 5-way. And when we do averaging, it kicks out. I'm not sure that fit on the screen. Let me do it here. So if I have 80, let's make it even better. If this is 81, this has to be 79 if the average of the three numbers is 80 because it has to be equidistant. When the equidistant on both sides, they just cancel each other out. So again, if this was 75 and this was 80, and I asked you what the third number is, to have an average of 80, it has to be 85. You don't even need to do any math there because equidistant like this. You could also do the math, 75 plus 80 plus x over 3 equals 80. Now if you do that, you get 240, and you get 240 minus 155, and you should get 85. Yep, you do, okay? So there's a lot going on this bugger. It's a good question. Okay, 15. You know what? We're going 45 minutes. How many questions are left in this section? Yeah, why don't we stop at this point? Because there's two other super meaty problems, if I remember this right. So let's just leave this at here. Again, Greg at GregsTutoringNYC at gmail.com. We are trying to beat to death a lot of SHSAT-like examples. In this case, it can actually be the examples. I will probably do an Ask Me Anything again later. I got a few questions yesterday on that. I think I helped the people who asked. The problem is how to capture the questions on a replay, because I think I let it run yesterday for 3 hours, and YouTube eventually died on it. So let's just leave this in a good shape. Live long and prosper, people, and have a great day. And I'll probably do some more lightning rounds. I don't know if I might even do something again later if I'm feeling up to it. So what do we have left? We have all of August, all of September, and pretty much all of October. So there's about 3 months left now. It's a lot of time and also not a lot of time at the same time. So now is a good time to start pacing out what you're doing and trying to fine-tuning it. If you're doing this by yourself, the most important thing is to have your discipline up and be consistent and make sure you're using good sources of material. I don't really recommend a book because a lot of the books have problems, but there's other ways to do this, including hiring me, obviously, so I'm biased. But I truly do believe, even notwithstanding my bias, that people should hire a tutor at some point, even if it's at the very end. I can't tell you how many kids and families I see, even families who have the money for it, who say, no, he's getting along fine, no, he got 100 and all the things, and afterwards they say, oh, he didn't get a score, and now we want to go in because you can actually check to see your answers. You have to send a special inquiry to do that. And they go in at the end to find out which problems the kid got wrong. And that's upside down. That's backwards. That's not the way you should be doing it. Don't take the test, not get the cutoff score, and then decide you want to see where your strengths and weaknesses are. You have to do them on the other side. So I crawl into kids' brains. Not only can I solve a lot of the problems, but I can crawl into kids' brains, figure out what their strengths and weaknesses are, work on a pacing strategy, work on a strategy of how to even start a test. You don't necessarily start in problem 1 and just go. Okay? Which section do I start? Which kind of problem do I do? There's the grid-ins, there's the there's the grammar, there's the reading comprehension. There's a whole bunch of things you need to figure out and do here, involved in getting to where you need to be. Where hiring a tutor is just the right thing to do. And don't think you can do it in an hour. You know, don't hire a tutor for one session at the very end. You have to do 3 or 4 at the end, and they have to be for an hour and a half. You could see something like this chart problem. It probably took me 20 minutes to do that if I do it replay. So, and if you have a kid asking questions, sometimes you could do one problem and take an hour for a kid who doesn't know the topic or something like that. So there's not a lot done you can get done. And if there's 10 topics, that's a lot that's going to go on there. Now, do you have to cut through the chase off? Then yes, right? You can't go on indefinitely and beating these things to death, to death, to death, to death, to death. But that's basically the deal. So I would suggest to anybody. In fact, I would suggest to you that even if you're going to a tutoring center or you have a tutor already, hire me anyway. All right? It's always worth getting a second viewpoint, because some tutors only concentrate on certain things. Some have specializations. Some believe certain parts are worth more than others, and somebody else doesn't. And what's important is to get the mix. That's why you might ask me, like, which book is best? Get more than one book. Don't just use one book, right? Even though I'm not suggesting one. I mean, it's the top 3. If you get one of the top 3, get a second of the top 3. Or go online and get another source. Even sometimes a weak source. But a problem with a lot of the sources, even good ones, is there's errors, and they make cookie cutter books. So they might take a book for, you know, the SAT and just kind of wiggle it around and make it for the ISEE. And then wiggle it around and make it for the SHSAT. That's not the best thing there to do. And you could argue I'm doing that slightly with some of the examples. Like you're tutoring for the SHSAT, but I have examples I use when I tutor kids. If I do them online, then I don't have those examples anymore. All right, so I'm chasing my tail here. I'm also giving you topics. What I'm trying to do with some of these YouTubes is less the exact problems than trying to get you guys to be cognitively aware and getting the savvy of problem-solving savvy and trying to go out of the box, right? So at one level, we're doing this at the atomic level. We're low down to a specific problem, but I want you guys to back off and address this more higher up. Am I studying properly? Am I eating healthy? Am I sleeping healthy? Right? All these kind of things. Am I doing this without any distractions? That's just as important as knowing what the range means. It really is. And a lot of families don't consider that when they're like, oh, he's taken the test and he tells me he gets 100. Well, what if he's really not? And I have to say, every kid I tutor is the same way. Whether I'm doing a kid anew or not. Oh yeah, I did a practice test. I almost got 100. All right, let's sit down and go over some of the examples. And this one's wrong, that one's wrong, that one's wrong, that one's wrong. Oh, my dad checked it for me. Well, your dad's not going to SHSAT. Your dad graduated 25 years ago. So I graduated a bit more than that, but this is what I do, and I'm expert at it. So, all right, I'm beating this to death. Again, live long and prosper. And if you guys have any questions, hit me up at GregsTutoringNYC at gmail.com. And let me pop that up just before I go. It's not really going to show there. Okay, hit me up an email, bros. All right, everybody, have a great day.